We are the Gujarat Technological University. Since its inception over a decade ago, GTU has been empowering young and curating minds to realize their true potential. Over 4 lakh inspired students are enrolled with one of the premier academic universities in India. With more than 450 affiliated colleges in its fold operating across 5 zones of the state, GTU, the International Innovative University, your place to move forward.
Hello dear students, today we will going to study about the new article that is solar cells. Many times we came across this word solar cells which is working on the principle of photovoltaic effect. The light radiations which are coming out from the sun and reaching to our earth surface. Have you ever imagined we can utilize these light waves or these radiations to generate the electricity? So the principle on which solar cells are working is the photovoltaic effect. The photovoltaic effect is the creation of voltage and electric current in a material upon the exposure of light. So consider a simple material, no matter whether it is a conductor, semiconductor or insulator. For now onwards, you consider any type of material. When you are exposing the light and when the light is incident on the material, then some amount of light energy will be stored by the material, as we all know, and the remaining amount of energy will be dissipated in the form of heat. So the stored amount of light energy can be utilized to generate the voltage and electric current inside the material. So this is the combination of physical and chemical phenomenon. The photovoltaic effect was discovered by Alexander Edmund Becquerel in 1839. It was analyzed in a junction, basically it was a PN junction formed between an electrode, that is a platinum, and an electrolyte. Electrolyte was used as the solution of silver chloride. The first, remember this is very important, the first ever solid state photovoltaic device was built using a silicon PN junction. We came across many semiconductor material. So instead of solar cells, we can now consider this article as a semiconductor PN junction diode or semiconductor solar cell, which is first ever made by silicon semiconductor by Russell Ohl in 1939, exactly after a century from the discovery of photovoltaic effect. Solar cells and photodetectors, these are the devices which can be utilized to convert an optical input into the current. So, photodetector, which can only detect the photon light radiations. We also know, along with the solar radiations, the light waves of many other frequencies like UV, IR, X-ray, gamma rays are also grouping, but the photodetectors mainly utilize the photon light waves. A solar cell is an example of photovoltaic device, that is a device generates voltage when exposed to light. As discussed earlier, the functioning of a solar cell is similar to the photodiode, that is the photodetector. It is a photodiode that is unbiased. This is very important. Unbiased means no external voltage is applied to the device and connected to a load. So we are not applying any voltage, but the excess amount of light energy which exposed to the material, or here particularly the semiconductor, can be sorted out with the connection of a load, that is impedance. There are three qualitative differences between a solar cell and photodetectors. So firstly, we will discuss the difference because these two are the different devices. A photodiode, that is our solar cell, works on a narrow range of wavelength, while solar cell need to work over a broad spectral range that is known as a solar spectrum. This is the major difference. Solar cells are typically wide area devices to maximize the exposure. Maximum amount of light energy can be utilized in order to convert their mechanism into voltage and electric current. So the wide area has been occupied in the solar cell. In photodiodes, the metric means in the front surface of the solar cell or photodetectors, the regions have been prepared. These regions are called, or these sections are called, the matrice or metric is quantum efficiency, which defines the signal to noise ratio, while for solar cells it is the power conversion efficiency, means how much light radiation is converting, or what is the percentage of the light radiation is converting into the voltage or electric current, which is the power delivered per incident solar energy. So these three were the major differences between a solar cell and the photodetector, for your kind knowledge. Now we will go through the construction of a solar cell. As you can see from this figure, a simple solar cell is nothing but a PN junction diode. You can see from the figure here the P-type silicon is utilized. Here the N-type silicon is utilized. The N-type silicon is the top surface, P-type silicon is the bottom surface, and in between the depletion layer have been utilized. The front, the topmost surface is of the glass lens, as here we can see. The metallic contacts have been utilized, which are working as an electrode. This is very much important, which are the conducting strips. As we all know, in N-type silicon we have negative electrons. In P-type silicon we have positive holes. And the bottommost layer is we have used as substrate base, and these metallic contacts are further utilized to measure the converted voltage and electric current to define power to incident light ratio. Let's go through the construction in detail. The N region is heavily doped and thin so that the light can penetrate through it easily, and that's why we have kept the N junction or N-type silicon layer at the second stage. The P region is lightly doped so that most of the depletion region lies in the P side, as we can see from the figure. The penetration depends on the wavelength, and absorption coefficient increases as the wavelength decreases. So, in order to have the maximum utilization of light, the increased wavelength should be there utilized. And here, the glass lens effect is utilized in such a way that maximum light should be penetrated inside the PN junction diode. Now we will see the working of this solar cell. Basically, when the light waves are incident on the PN junction diode, so first of all there is a generation of electron and hole pairs. You can see here, this is the electron and this is the hole. So electron hole pairs are mainly created in the depletion region. This is the depletion region, neither in N junction, neither in P junction. In the in-between junction, the electron hole pairs are created, and due to the built-in potential and electric field, electrons move to the N region and the holes to the P region. You can see the positive charge, that is of hole, is traveling towards the P-type silicon, and the negative charge, that is electron, is traveling towards the n-type silicon. So when an external load is applied, the excess electrons travel through the load to recombine with the excess holes, which takes place in the depletion region, and hence electron and hole pairs are generated. These electron and hole pairs are further utilized to create voltage and electric current inside the given material. The shorter wavelength, which means the higher absorption coefficient, are absorbed in the N region, and the longer wavelengths are absorbed in the bulk of the P region. Some of the electron hole pairs generated in this region can also contribute to the current. So, first of all, the photons were also contributed to the generation of current. Moreover, electron and hole pairs are also supporting it. Typically, these are electron hole pairs that are generated within the minority carrier diffusion length, that is Le for electrons in the p side and Lh for holes in the n side. See here, they have mentioned the length for the holes and electrons in the p and n type regions, which is the diffusion length. Carriers produced in this region can also diffuse into the depletion region and contribute to the current. Thus, the total width of the region that contributes to the solar cell current is WD, that is the depletion width. Here you can see this is the depletion width plus the diffusion length of electron in n-type semiconductor plus the diffusion length of holes in p-type semiconductor. So this is the total width of the region which contributes to the solar cell current. And as I mentioned earlier, WD is the depletion width. The carriers are extracted by metal electrodes. On other side, a finger electrode is used on the top to make the electrical contact so that there is sufficient surface for light to penetrate. So this was all about the principle, that is of photovoltaic effect, its construction of PN junction diode, how these P-type semiconductor and type semiconductors are arranged inside the solar cell construction, the working in which the main prospect is the recombination of electrons and holes, which majorly contribute to generate electric current inside the PN junction diode, which is further measured by the connected voltmeter, and utilizing the value of voltmeter reading and the known impedance which we have earlier connected to the photovoltaic device, we can easily calculate the electric current according to Ohm's law. So this is the most important article in view of your GTU examination. Be prepared for this question to be asked in 7 marks. Thanks for visiting this lecture.